Balance the following redox reaction in basic solution using the half reaction method. To begin a problem like this, what we need to do first is determine which are the species in each half reaction. I'm going to begin by putting the arsenic and As2O5 in one piece. I'm going to do the NO3-1 to NO in the other. Starting with the one on the left, I can see for the main element we're dealing with arsenic, there are 2 on the right, therefore the first step will be to balance and put 2 on the left. The next thing I need to do is add water to balance the oxygen, so we have 2As plus 5H2O, giving us As2O5. Now we need to balance the hydrogens using hydrogen ions, so 2As plus 5H2O, that makes 10 on the left side. So As2O5 plus 10 H plus. Now what we have to do is balance off the charge. If I take a look on the left side, I can see it's neutral. The right side, it's plus 10, so I need to add 10 electrons to that side. In the other reaction, the nitrogen's already balanced. I can jump straight to adding 2 water to balance off the oxygens. Then I need to add hydrogen ions to balance off the hydrogen, so we have NO3-1 plus 4H plus, giving me NO plus 2H2O. And looking at the charges here, I can see the right-hand side is neutral with 0 charge, and on the left-hand side, I can see a plus 4 and a minus 1 is plus 3, so I have to add 3 electrons here. Just as a side note, it is a great double check to make sure you've got at least electrons on each side to know it's redox. Remember, one has to oxidize, one has to reduce. Now, looking at the 2 sets of electrons, they don't balance. I'm going to need to multiply this one by 3 and this one by 10 in order to balance them and then combine the reactions. So, beginning off, 3 times 2 gives me 6 arsenic. 3 times 5 is 15 water, and that's all on the reactant side of this one. Jumping to the other one, we've got 10 NO3-1 plus 40 H plus. I'm going to skip writing the electrons because the whole point was as we balance those, so we don't really need to put them there just to cancel them out. Now I'm jumping to the product side. I have 30 H plus. Again, we don't need the electrons, plus 3 As2O5 plus 10 NO plus 20 H2O. Now, something just to be aware of, when you have OHs and number zeros, like I'm just underlining the 30 to remind me that's 30H plus, not 3OH. It's an easy mistake to make when you're in a hurry and doing a test. Now what I'm going to do is very quickly cancel off the overlaps between each side. For example, water, there's 15 on this side, 20 on the other, so I'm going to turn this into just 5 water over here. I have 40H plus on one side, 30 on the other, so I'm going to turn this into 10 over here. So I have 6 As plus 10 NO3 minus plus 10 H plus, giving us 3 As2O5 plus 10 NO plus 5 H2O. This is great. It's balanced in acidic. We need to turn this into basic. So I'm going to add 10 hydroxides to each side. That will cancel out the hydrogens, so we end up with 6 As plus 10 NO3 minus plus, now hydrogens and hydroxides will combine to make water at 10 water, giving us 3 As2O5 plus 10 NO plus 5 H2O plus 10 OH minus. Now, I have overlap again. I'm going to cancel out the excess water on one side and combine it into the other to give us our final at 6 As plus 10 NO3 minus plus 5 H2O, giving us 3 H2O5 plus 10 NO plus 10 hydroxides. And that is your balanced redox reaction in BASIC using the half reaction method.